Question 9. Water is poured into a tank at a constant rate of 500 cm cube per second. The depth of water in the tank t seconds after filling starts is h centimeters. When the depth of water in the tank is h centimeters, the volume is v centimeters cube of water in the tank is given by, okay, so this is the volume actually, the equation here. The first question asks, find the rate at which h is increasing at the instant when h is equal to 10 centimeters. So imagine it's gonna look something like this. So the water is poured into a tank and the speed is 500 cm cube per second, right? And the depth of water after the time has already been t seconds. The water height here is h centimeters. And the volume here is equal to this equation. So the volume of water is equal to the equation above here. And so what they want to know is that they want to find the rate in terms of cm per second of which h is increasing, of course, because we keep pouring the water in. But when h is equal to centimeters, that is what they want to know. So when h is equal to 10 centimeters. So let's try to understand different values first. So the 500 centimeters cube per second here is actually the rate of volume compared to time, right? And the rate here that is given by the formula is actually the rate of volume compared to the rate of height change. So yeah, and what the question is asking is actually the rate of height change in comparison to the rate of time, right? And there is this differentiation formula which says that if the differentiation here of volume compared to time is equal to the differentiation of volume compared to height multiply the rate of change of height in compared to time. And we already know that the left hand side is 500 from the question, and this is what we don't know, but we can find from the formula here, right? And this is what we also don't know. It's actually what we're trying to find. So next step, we're going to differentiate this so we will have dv by dh equals to, so we kick the power here to the front, right? So 4/3 multiplied by 3 in the brackets 25 plus h. And what do we do to the power after we kick it? We minus 1. And the differentiation of this constant is 0, so we don't write it down. Okay, let's rearrange the equation a little bit. So we'll have 4 in the brackets 25 plus h to to the power of 2 here. And we know that the height is equal to 10, right? So when h is equal to 10, we know that the dv by dh is equal to 4. We substitute here with 10, and we will get 4,900. So we already know that this value is equal to 4,900. Let's write it down again here. 500 equal 4,900 multiplied by what we're trying to find. And so we know that the rate of change here is equal to 500 divided by 4,900, which is equal to 0.102 centimeters per second. Next up, at another instant, the rate at which h is increasing is 0.075 centimeters per second. So this is height by the rate of height by time. They ask us to find the value of v at this instant. So again, the rate of change of volume in compared to time is equal to the rate of volume by height multiplied by the rate of height by time. That is from the previous question, and we know that the left hand side is always 500, and we already know that the rate of change here is equal to 425 plus h squared here multiplied by 0.075. So we can do this. We can divide the whole equation by 4 times 0.075. So the right hand side will be left with this, and so on the left hand side we'll have 5,000 over 3. This is from the calculator, and on the right hand side we'll have h squared plus 2 times 25 h times 25 square, right? Next, I will balance the equation by deduct the left hand side to 0, right? And from the calculator, we'll have h squared plus 50h minus 3125 over 3. So next, I will plug this into the calculator, and I will have h equals to 15.82 or minus 65.82. And of course, it is a height, so height cannot be negative. So we'll go with this answer. And they want to know the volume, right? And the volume equation from the question is 4 over 3 5 plus h, which is 15.82 to the power of 3 minus 62500 over 3, right? This is from the last question, and this gives us 69900 centimeters